Hello, friends. Really excited to be here with you today. Going to be looking at two of the divide and conquer algorithms. Divide and conquer basically means if you've got one problem, what you want to do is see if you can break that up into smaller problems. And so the two algorithms that we're going to look at to do this are the merge sort and the quick sort methods. Now, um, a little bit about those two. Sorting, let's say that you want to say look for a house. If you want to see only the houses in your price range, one example of an application of sorting might be that you'll want to take all the available possible house listings that are in your, you want to first sort them by distance and say, okay, how many are within a certain distance of where it is that we're looking for? And then the second thing you'd want to do is, okay, of the ones that are within that certain distance, now let's sort them by price. And then the ones that are below a threshold or within a certain threshold that the user sets, those are the ones that we're going to return to the user. And then we can, again, maybe have a dollar per square foot metric, a number of times viewed popularity metric or something like that. We can sort things again and display them in some certain order. And so Google and a lot of other places like that use sorting algorithms. And so two of the algorithms we're going to look at are quick sort and merge sort. And there's great explanations of these on the internet. So for today's discussion, I'll be working inside of a virtual machine. Actually, I need to come here, hit share the screen first. Okay, so this is my desktop, and as I said, I'm going to be working inside a virtual machine. This semester, I'm probably going to be using a lot of what they refer to as a Hyper-V virtual machine. So the problem description says, for this assignment, students are asked to examine merge sort and quick sort. Research the algorithms, make a prediction about which algorithm will perform better, memory requirements, number of operations, algorithms. So this is all great stuff that you can read about in any of the books. One of the books that I had recommended was the elementary algorithm text. One of the things that I've actually been leaning on pretty hard is the Introduction to Java Programming by Daniel Lang. It turns out he's actually got a couple of pretty good chapters in there that help do this kind of work. Daniel also had a way you could implement both codes. And so I've got Daniel's, this is Daniel Lang's 10th edition, and this is out of the sorting chapter. And they actually have both the merge sort and the quick sort. They have a brief listing of the algorithm. This is the algorithm. It doesn't implement the code. This is just describing the algorithm. And then further down in the book, they've actually got the implementation. And so they also have that for the insertion sort. So I went ahead and I got these both set up. I used a little bit of object-oriented programming. Hopefully that adds to make things simpler and easier to understand. If it makes things more confusing, please just let me know and I'll be happy to readjust. All right, so the first thing I said was I'm going to use a object-oriented programming. I said I want to create this fixture and I'm going to define it with a class called text fixture. And I'm doing this in the project folder, Algorithms Week 1. I'm using the Eclipse Integrated Development Environment, and I'm using the Java programming language. All right, so I start out and I said, time is going to be in milliseconds, so that's just a simple print statement, and you can see that when I run the code, it prints out like that. I also have a hello world up here. It doesn't actually add much to the code, it just makes me feel happier. We don't need it right now, so delete it, make sure everything still runs. Okay, so the next thing I said was, let's print off our header. So our header is array size, the merge sort time, and a quick sort time. And what I use that for is, this is a Google Sheet. It just makes it really easy for you to copy and paste this in. Google Sheets liked it when I used tabs, so that's why I used the tabs in this. And then I said, okay, I want you to repeat this in a for loop. And basically what I said was, I want to repeat this same exact process, and I want to repeat it maybe 20 times. So the general idea is that if you only run it once, you might run into something where Windows decides to run an update, or I'm running a virtual machine, so it might decide to throttle back the virtual machine, or Ubuntu might decide to do something wonky. But if you run it 20 times, there's a good chance that you'll get one clean run. Now, if you're not comfortable with that, maybe you want to run it 200 times. It doesn't care. You know, the program does not care. If you want to run it 200 times, it's as simple as changing that number to a 200 and then you run it. This is a relatively smaller one, so it takes a similar amount of time, but consistently the smallest number on the right-hand column is, oh, hey, we got a 3. So I'm going to tell you that was the one time that nothing else was going on. So that was definitely the fastest. Let's just scroll through that again. I've got a 12. See if I've got any single-digit ones. I've got a 10, got a 6. Oh, yeah, no, 4 is still the fastest. So this is a great example of when it'd be nice to sort it. So you come down here, grab this, and you can just grab it, copy it, go in here to this, get to a clean spot, paste our data in. It goes in nicely. Let's just sort this. Using the Google Sheets is always a little interesting to me. Sort by column E, sort, let's see, sort range. Let's do column F and do sort. So consistently 6 is the smallest one. So I'll do data and then sort range, and let's go by column G. So 6 and 3. 6 and 3, already we're saying that the merge sort is slightly slower. Anyway, I ran this multiple times, and I ran my code for also different array sizes. And what you see is when the array size is smaller, you get smaller times. When the array size gets bigger, you get bigger run times in milliseconds. And when you get kind of to a significantly large array, then you start to see a fairly large distribution in the time. Sometimes, though, we still will have some quick runs. And so anyway, just wanted to walk you through my code right quick. So I've got this for loop. It runs as many times as you want it to run. I gave my fixture the ability to set the array size. That way you can have one array size and run it multiple times. And I added that to my table so that when I was creating this graph, all I had to do was just copy and paste a bunch of stuff over, and it just worked. So I print off the array size, and then I go about setting up everything else that I need. So the first thing I do is I say, hey, let's get the starting array. And I just do that by creating a single dimensional array. And then I say, all right, let's fill it up. And then let's make a copy for the merge sort. And let's make a copy for the quick sort. Now, you'll notice there's a couple of things highlighted out when I did this. Those are debugging statements. And if you want to use them, then by all means use them. I know when I'm running the bigger sets, and after I was comfortable with everything was working right, then I went ahead and took those out because it just kind of clutters up what I have for printing off for my results. Okay, so like I said, I fill up the array, and then I copy the array, so I've got one for the merge sort, and then I copy the array again, so I've got one for the quick sort. All of my arrays are the same size, they've got all identical numbers, so it is always an apples to apples comparison. Okay, then we're looking at doing the sorting. So a little bit of redundancy here. Every time I go through the for loop, I create a new variable called start time, and it overwrites the old variable called start time when I'm iterating through the loop. So I probably could have sped my code up just a little bit, but this is something that I'm doing a whole lot of other work, and I'm only doing this a couple hundred times. I said, yes, I'm not feeling interested or concerned with that. Anyway, I call the merge sort, and then I print off the time, and then I call a quick sort and I print off the time. And that's how we generate this nice little table. Okay, so that is what my main method looks like. It's basically a loop, and I can control how many things I have in the loop, and I can control how many things I'm going to sort for each array. And that works pretty well to generate the data and so that I can look at it. Now, the next thing I wanted to show you was what does the actual guts of this look like. So I like to read this like a story. So text fixture equals new fixture. I'm just using the default constructor on my object, so I don't actually have a constructor on this side. Then print statement, for loop control, okay, set array size. So here I've got a private variable called array size, and then I've got set array size. So this is where I pass in what I want my array size to be, and I say, hey, whatever my local private variable is for array size, I want that to be set to this new value. And so it does a nice little job of color coding these in such a way that you can see what those values are. So that's nice. And then once I've set that, then I just use the get array size, which is just a standard getter, and it returns whatever our array size is. So I can use that to say, okay, this is what our array size is, and then we use that exact same call here when we're setting up our starting array, our merge sort array, and our quick sort array. The fill array, basic, not real complicated. I say, hey, whatever your starting array is, I just want you to fill that up, going through all the addresses with some random number. And to make sure that this scaled and didn't have a whole lot of repeated numbers, I said, hey, tell you what, take 2,000 times whatever this little floating point number is, take that times 2,000 times the length of the array. And that just make sure that I have plenty of random numbers to work with. Odds of getting a repeat go down. It's 1 in 2,000, you know, for every array size. So could I still get repeats? Yes. Both arrays have to deal with that. So anyway, this is how I fill up the array. And then I come in here and I say, all right, make a copy. So I've got copy array. And copy array, again, I had old code in there to print the array, and so you can see that it just prints out this. I added this little if statement in here just to make it, basically it'll do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it goes chunk, next line. And the idea is it just prints a little prettier. Copy array, I say, okay, copy from what to what. I just do a for loop and I say, hey, whatever's in this array, assign that to this array. And so that's the copy. And then I'd get down here and I say, all right, let's do the merge sort. Merge sort, delete some white space right here so you can see. Here is how I came up with this absolutely brilliant, absolutely well-written code. mergesort.java, listing 23.6 from Daniel Lang. So this is the book that we use in Computer Science 1 and Computer Science 2, and I do encourage everyone to go out and get a copy of that book because it is excellent. And you will find that when you get ready to do this, if you copy it directly out of the book without manually typing it in, you do have some problems. But you can reference the book, get those problems worked out, and this is what the code looks like. And the last little part here, this is where Daniel puts his main method at the bottom. So he prototypes at the top and then does the main method at the bottom. And then he prints out his list to show that it worked. Since we're doing rather large lists to show performance comparison, I don't have you printing off the list, so I disabled that. Or I didn't use that in my main method. By the way, this is the one that has the main method. So this is the part that we can actually execute. So again, we're down here doing the merge sort. I called it merge sort the array. Deleted white space, so I've got to say that again. So we've got this merge sort the array. We call all of this function. It says, hey, let's make a first half array, and it's the new int length divided by 2 array copy. And so that's built-in system way of doing that. And we do list from 0 up to first half. Cool. And then we say, all right, now sort the first half. And then we grab the second half length and list length. And then we say, hey, copy from list to second half. And then we say, all right, now go merge sort the second half. And then we say, all right, when you get the first half sorted and the second half sorted, now let's go ahead and put those together. And so here's the algorithm for merging those together. The thing is, there's this if statement here at the very beginning. And it's if list.length is greater than 1, then you do this. What happens if it's no longer greater than 1? Well, then you can't go in and do this. And so it'll kick it back and say, nope, we're good. We're ready for the next part. And that's when it'll kick back to this part, which is merging it together. So we've got list 1, list 2, and our temporary. That corresponds to our first half, our second half, and our list. And so the idea is we've got these 3 indexes. And it says while current list, and we do that. Otherwise, we do this little thing. And basically what this does is it takes the 2 lists and it says, all right, start folding them back together in the way that makes sense. And so that's the merge sort, and it does require you to create a second array. Now, that runs, and it prints out what the time was. Now we've got the next one. We've already created the second array, and now we just come in and we do quick sort. Again, how did I do quick sort? Here's Daniel Lang's book. Here's a nice diagram on merge sort. And then you go down here, and now we've got a nice long discussion about quick sort. And I would encourage everyone to go out, like I said, get a copy of the book, start reading through it, because there's a lot of amazing information in here. They describe the algorithm first, and then they go ahead and implement it. And then they've got some nice discussion of it. Okay. So we pass in the list, we do a quick sort, and then this is the recursive call. And so it says quick sort of list, and it keeps going, list, until there's no list left to quick sort. And so we pick a pivot point, and basically it's always taking the smallest number and moving it up to the front, doing a lot of nice work. And it says, here's how these things go and how everything's get sorted out. And the nice thing about this is it takes less memory, and it also runs faster. So anyway, I just wanted to give you a quick little, here's where everything goes into. I wanted to show you it can be done in Java using an array. So I would say most everything we were doing there is stuff that we now cover in Computer Science 1. So a little bit of object-oriented code, we dip our toe into that. If you've got CS2, you'll probably be more comfortable with that. But you don't have to use that. You could do that all with just custom methods, which we cover in CS1, using arrays, which we cover in CS1, and for loops and things like that, which we all cover in a freshman level programming class. Now, ways that you can make this more interesting. We talked about sorting an array because that's what Daniel's book does. If you want to get creative and you want to ask the question, how does this change if we're doing something like sorting an array list? Does it make sense to sort something like a queue or a stack, or do those have different purposes? And the concept that I want to leave you with is this. Lots of things make sense for lots of different reasons. And when we're trying to solve problem A, we can't necessarily think about problems that follow on after that. We focus on solving the problem that we're dealing with. And so this is one example of how this breaks down and how this starts to work. Is this going to be in the case in every situation? No. How far do I want you to go into the weeds on this? My answer to that is, if you find this extremely interesting, and then by all means, enjoy your time and have some fun with this. If you find this to be a very tiresome process, and this is not one that you were very excited about, then I would say try to focus your energy on something that is more interesting to you. But I would, as a minimum, I want you to go and implement these two different algorithms, and I want you to see them actually work in code. And I want you to write a code that allows you to run the operation enough times that you're like, you know what? Yes, I agree. Merge sort is slower than quick sort in this situation. Now, the flip side of that is, your code doesn't have to be perfect, meaning it doesn't have to be clean. You saw how mine had stuff commented out and things like that. It wasn't perfectly well organized. I'm fine with all of that. But in your video, I would like you to show a little bit about what your code is and where you got your ideas for your code and stuff like that. My method was I just went out and found one that was already in a book because I know it was there and I know it would work. And this is a week where I'm also trying to do a national training, and we're wrapping up grant season and stuff like that and getting ready for fall grants and things. And we've got advising and all sorts of other things going on. So where I am in my life today is, oh, hey, what do you know? That's actually written in the book. Okay, let's just go use that one, moving on. You find it on the internet, that works too. Some days are going to be like that. Other days, you're going to have time and you're going to have interest and you're going to be able to implement the algorithms from scratch. Those are wonderful days for me. And those are programs that I'm proud of for years to come. So the concept is, I want you to get your hands on the material. Put the fingers on the keyboard, make some programs that work. I want you to get kind of an intuitive feel for what's the difference between these two algorithms. And I want you to take a little bit of time and I want you to dig through whatever you can find and actually look at the analysis and be like, okay, this is why this algorithm is faster in this case. This is why this algorithm is slower in this case. One of the things that you will find is when you're using an array list versus using an array. An array list, you have to work through the list systematically to get to the point where you're trying to look at. Whereas with an array, you say, go to this point, and it's constant time. So anyway, there are a lot of interesting nuances to this problem, and it can be relatively straightforward, but it doesn't have to be. And I want you to have as much fun with this as you can. I appreciate all your time. I look forward to seeing you again real soon. I look forward to seeing what you're all able to accomplish. So with that, I thank you all for your time. I hope you have a wonderful day.